All right, very well. By dint of force, yes. Let me go ahead and start. It's a great privilege to be here. We've had a really good time, and you guys are neat. It has been one of the most exciting meetings I've been to in a while. It's obvious there's a lot of passion in the room, and a lot of commonality actually in the thinking I've been hearing in the talks. In comparison, I think you'll find to what we've been thinking. Fundamentally, I guess I'd say we all probably understand, it seems, that our job as engineering educators at some most basic level is to inspire confidence. There are a lot of different theories on, I suppose, how to do that, but I think that's what we're working to do with our folks. And the trick, I guess, in a somewhat larger context is that the people after World War II, in some respects, had a clear mandate about what the plan was. They were working with people who, in a lot of cases, had a great physical connection to the world, had done a lot of things. They were ham radio operators. They'd taken their car apart. They a million other physical experiences that they'd had. And there was a great hunger, I think, in that generation or a couple of generations of people to really understand how the things they already knew how to do in some respects really worked. Now so what we saw was the development of sort of the engineering science approach to teaching. And we also, at that same time, enjoyed the development of the modern computer in all its many forms. And so as you look to the challenge going ahead forward in the next 50 years, I don't think those two things are going to change. In other words, we're not likely to see engineering science become less important, and the computer is certainly not going away. The difference, I think, is that the people we're dealing with now are more sophisticated than ever in some ways, but in other ways are less connected, perhaps, with the physical things. They're not ham radio operators. They don't fix their car. I'm not even sure it's possible to fix your car or learn anything by taking apart a phone at this point. So they're robbed, in some sense, of the preparatory experiences that we used to expect for engineers. And our challenge, in a good sense, is making sure that they understand the wonder of the things that have been developed in its miraculous ability to actually make things. So you guys interrupt me when you want, please. Okay, yeah, okay, I'll keep rolling to you. Yeah, I see, that's gonna happen, right? Yeah. So perhaps in following too closely with the man's instructions, we basically went through the 4 questions, if you follow me, just to summarize some thoughts. And I don't think they're apparently unique to our group. One, in particular, that I'd highlight for you guys, even just looking at your presentations. You know, if you look at what you guys did, brought the hands-on things, brought multimedia in front of us in such a short time, it reaches at a pet peeve, the strong one of mine, but I think echoed in some way all throughout our group, which is a question about whether we're misdirecting our resources right now. I'm very, for example, just personally, I'll let the group strangle me, but I'm personally unclear about the online education very much. And I wonder whether that's not robbing resources from some of the hands-on things that might be really important right now for engineering education. That is conflicting head-on with a need to not simply present analytical methods to people anymore. That's, I think, the reductionist word. And instead expose them to the concept of systems thinking, of being able to put together these ideas to make creative things that are, in some respects, a system of systems these days. In other words, successful products are not just a couple of vacuum tubes. It is an interdisciplinary collection, as you know, of a lot of things. Part of our concern is that I think the only way to get across some comfort with that complexity is to not expect that you're going to be presenting those things in a single class. And so there's a need, I think, felt throughout our group that a spiral curriculum, something where examples are seen again and again from different perspectives, is important. And there's a fairly serious question about whether, back to the first bullet, there's just some institutional rigidness that's severely limiting us in the ability to do things like that. And finally, perhaps related to that is this notion that it's difficult to find ways to get students to understand that, particularly as they're building a system of systems, that it's okay, in fact, appropriate that you modularize your approach to those problems, and that failure within a module is not only okay, it's probably a good thing. It'll make you think about both the system some more and also make sure that you're not building on a house of cards. And the question is, how do we convey to them an orderly approach, not necessarily a uniform approach across everyone, but an orderly personal approach that they need to develop so that they can tackle problems that, looked at as a whole might frankly be frightening. For us within our group, we found that tackling those things head on is a wonderful thing. I would not say in our group that it was consistent that we were all doing the exact same sort of project in class. We have some people doing very hands-on things in a classroom laboratory environment. We have other people out in the world doing outreach activities where they're but the common theme in everything that we were doing was we all had groups of students building to solve people's problems somewhere. Sometimes it was in Bolivia, sometimes it was in our teaching laboratory, but we were all trying to convey a sense of engineering to our students by embedding them in real-world problems, by putting them in front of a customer requirement. It could have been one that was formulated in the class, it could be one from outside the class, but getting them to engage with a problem in a way that it became something personal for them, that they were excited about wanting to do it, and excited about being willing to start the process of modularly thinking about building a system of systems, being willing to accept. In other words, we're all working in our different contexts to find ways to get them to be comfortable with the notion that an intermediate failure is fine, for lack of a better, I'm not sure failure is necessarily the right word, but in other words, an intermediate setback perhaps, or not what you expected, there's nothing wrong with that, and in fact it's a good thing. Also, that the notion that having some sense beyond just pure analysis, beyond just pure application of math, that some sense of a qualitative structure of the problem was absolutely critical in guiding the right level of modeling. In other words, that notion I've heard an engineer described as someone who knows what to ignore, and getting them to develop that sense is something that we're all working very hard to do in the classes, and of course in the limited time we have to give them tight experiences that let them see these points relatively quickly during the term while they're trying to do something ambitious. Documentation, we were a little unsure about what that question was after, actually, so that's the italics and the question mark. And I suppose it's perfectly well directed at all the possible things it might mean. There was question about whether it meant professional documentation to each other or perhaps as a subset of that to our tenure committees or deans or department heads, or whether it meant how do we use documentation in the classroom to get the students to seal the deal on their understanding of what they're learning. We talked about both possible issues. Certainly, for example, for the junior faculty, this is a key, another personal bugaboo for me, I guess, since I sort of have the floor for a second. I think one thing we're very comfortable with is those of you who are working your butts off on doing something really cool at your institution, do not leave that on the table. There are ways to publish transactions level publications on education innovation. And I've learned a ton this week from seeing some of the things you guys are doing. Like one of the main things I've gotten is just to scumbag a bunch of examples I'm going to bring back to my classroom to use with things. So the point is it's an opportunity, I think, professionally for us not to miss, both because it shares information that I, for example, am incredibly excited to see, but also because, in other words, several people have echoed this. I certainly agree with it. I understand that teaching innovation is not necessarily the first thing in your tenure case. On the other hand, just playing along to that and not crowing about it, not making sure that you publish that sort of thing, I think would be crazy. And I believe that was a reasonable conclusion out of our group. The last one I'll say on this is, in the general question of assessment, I think there's actually a very serious question for groups like this one and the NAE in general to provide some vastly much needed guidance on what this actually should be. Stepping off my safety circle, I don't want to offend anyone exactly, but we've probably all sent in the NSF proposal where you're supposed to put in the section on, what am I doing for outreach? It doesn't matter, research proposal or not, it doesn't matter what you're doing. There's always some outreach piece and there's always some assessment part of that. And I think, I don't know how many of you have had the experience of calling an NSF program director asking, well, what is it you're looking for here? What exactly are we supposed to be doing? I'm being told, oh, well, that's for you to propose to. That's right. And also of having had the experience of asking an education educator, hey, will you collaborate with me on this? And I've personally, anyway, been laughed at by some of our education folks. Nah, you guys in engineering aren't going to be serious about doing the assessment in a way that, formal social sciences people would do this. So what I'm saying is this is either something that's under-resourced or under-thought thought out, or both sometimes. And we don't have an answer for this necessarily, but it's a pet peeve for me that we're often asked to think about this or report on this at ABET or an NSF proposal in some way or another, where it's not 100% clear to me that within the resources we have, I understand there are people who know how to do this. What I'm saying is for our group, within the resources that are available, how to do intelligent and informative assessment and documentation is not necessarily, at least I think to some of us in our group, an obvious thing. And finally, I'd say we all, I think, see a tremendous value in engaging students in learning in a space where they can actually build. And that may be outdoors in Bolivia, it may be in a laboratory classroom. I might try it on you this way. The flipped class notion is, of course, a wonderful and exciting thing. But I give you an argument that it is a symptom or one example of a larger educational innovation that we're all looking for, which is engagement. We want the students to be engaged in the problems we're talking about. Obviously, flipped classroom is certainly, in some instances, a wonderful way to do that. If you manage to get them to read about what you're going to talk about beforehand, then you can certainly, when you're face-to-face with them, use that time as an engagement time to ask them questions. But we all have found amongst ourselves that we have a lot of different methods for doing that. And so what I'm saying is rather than run off on one fad, I think there's a million ways that that can be done. Personally, I teach laboratory classes, and a lot of our group teach either build or even simulated build. In other words, it's imagine something you couldn't really even do, like a disaster in a city. But the point is you set up something where there is a problem for them to think about that they get stuck on. And I think all of us were in relative agreement that we found that when they had engaged in the thinking about the problem a little, realized that it was a system of systems solution that's necessary to solve it, and then realized what a challenge it is to pull that kind of thing together, they're mega excited about being in lecture to hear any theories you happen to have about that. And so I'm telling you, even when, for me at least, I'm okay with traditional lecturing as long as they care what I'm saying. In other words, I don't mind giving those. I just want them to be excited about why they're there, and that can be done in a bunch of different ways. So that was our thoughts about scale up, where actually getting them embedded in a problem is a really exciting thing. I think that there's a deep worry right now, that a lot of critically needed resources to maintain the residential campus and to be able to get them to have those sorts of experiences is being diverted to things that like online teaching that also, I'm sure, has a role. It's just that in the fad of new, if you follow me, it's not clear that the old is also being looked at and serviced in a useful way to make design studios and outdoor experiences that work for them. And finally, I guess a good concluding point, I'm pretty sure that's the last slide, is the value of events like that. This, I said, one of the highest quality professional events I've been to in a while. It has been really exciting being here. So this has been a lovely step, I think, for all of us. Wonderful thing to be here, and we're grateful for your time. Thank you.
Thank you, and I just happened to have a similar conversation with someone. I'm from Michigan, and the kids in mechanical engineering, some of the kids that are the best and come with this logical thought process are kids who have either worked on a farm
Yes.
or grown up on a farm.
Yeah, amen. Yeah.
They know how to fix things, they know how to put things together.
Yes.
I also come from the innovation group, and the systems approach we talked about in ways of interdisciplinary teaming with mechanical students, electrical students, computer science students, that would be a nice approach and also innovative, but very difficult to achieve in our current settings because we don't have
Yes.
disciplinary nature.
Yes.
So my question to you all is, have you taught classes like the fundamental dynamics class that you've been able to do a systems approach, and if so, share with us how?
No, I have an answer. I just don't want to be the only one talking. You guys first.
Well, in my curriculum, of course, I'm teaching systems analysis, and all of our students have to take it. And so I actually use the systems approach to develop it. So the students have to go through qualitative and quantitative analysis and decision-making all in one course. So engineers are traditionally really good at crunching the numbers and doing
Rebecca from Northeastern University. I just had thanks. I'm Rebecca from Northeastern University. I just had a question. I love the idea of the real world problems in the class. It's something I've tried to do myself through industrial partners and as well as incorporating my own research. I'm just wondering if you guys have other ideas. I love, the idea of the problem from Bolivia. How do you make those connections to pull those problems into the classroom? I think it's something that all of us would like to do. I'm just wondering if you have some examples of ways that you've been able to do that.
Oh, I comment on Bolivia. All right. So I'm the one that had the poster on Bolivia, and actually that is the challenge. So we're doing systems-based, work, but it's all extracurricular. It's through a student organization and through a study abroad tour. And that was actually my challenge, is how do we capture that and put it into the classroom? So we have not been able to do that.
And I do a course on transitioning infrastructure towards sort of sustainable infrastructure. And I spent a good 9 months doing presentations to local decision makers. A whole lot of nothing would happen. But every once in a while I would get a bite, and somebody would be interested, and then I would actually bring them into the class. And then at that point it became a sell on making sure that I pitched what the class was doing as something of value to them and their institution. And if I got over that barrier, then I found that they were often willing to sort of open up, information to us and all sorts of resources.
I have one more point too. I have one class where I do connect with real industry in a sophomore design class, but what I talked about here was actually a made-up scenario. And believe it or not, if I put it in sort of a real context and provide them choices